The introduction to our guest speaker, Blaine Baggett from Jet Propulsion Laboratories, and a JPL Fellow, is a recipient of NASA's Distinguished Service Medal, and he is got such a unique and interesting background. He is a producer of high quality astronomy and other topics, actually, videos, and has a long distinguished career working for PBS, the public broadcast system, making documentaries on some of which you may have seen, the Astronomers or the Spaceflight series. He also worked on NOVA, so many of you I'm sure have seen NOVA programs, and he's won Emmy and Peabody Awards and a whole bunch of awards that were too many for me even to list. So I had to cut it down to just this amount, and that is my introduction for Blaine Baggett. So with that, take it away, Blaine.
Well, first of all, thank you very much for having me. I'm very sorry that I can't be there in person. I was really looking forward to it. San Diego is just a great city, and I was looking forward to seeing the city as well as all of you. But maybe we can do it another time. The topic tonight is the moon. This particular talk, Moonstruck, I gave 1 year ago for the 50th anniversary of the moon landing at JPL, and was asked by Steve to go again with it. So here goes. Over my years of working in astronomy and planetary science and doing documentaries and working at JPL, I've really made a change in the way that I look at our solar system, because the more that I learn about our solar system, the more I appreciate the incredible diversity, not just in terms of the planets, but really the moons of the planets. And I think they're really more interesting than the planets for me at this point. And there's many scientists who I know feels the same way that would agree with me. For instance, if we go to Saturn, as we see here, look at these moons. Hyperion here looks like a seashell, and Pan reminds me of UFO. And Mimas, do we have any Star Wars fans out there? Yes, that's where George Lucas got this inspiration for how to portray the dark star. But there's a lot more to the moons here than unusual shapes and sizes. Saturn's moon Enceladus is a beautiful icy world, small in size, but enormous when it comes to the possibility of finding life. It's a place where geysers are constantly erupting, water crystals and chemical elements that hint of the possibility of life. And Titan also orbits Saturn. It's the only moon in our solar system having a substantial atmosphere, and that's because it's big. In fact, if it orbited the sun rather than first Saturn, we would call it a planet. And on its surface is evidence of rivers, and there are lakes, not of water, but of liquid ethane and methane. Some scientists are saying that it might be possible that this is a place where life might exist based on chemistry entirely different than here on Earth. And I'm excited that NASA has announced a new mission to go there called Dragonfly. And then there's Jupiter's moon, Europa. This is another icy world, and beneath its icy crust is a water world thought to contain more water than in all the oceans on Earth combined. And at JPL, we're hard at work on a mission to go to Europa right now. It's called Europa Clipper. There are nearly 200 moons in our solar system, and these moons, almost all of them, are to be found in the outer solar system. And if we move towards the sun, inward, we find a different story. Mars has two very small moons. Venus, Mercury have none. But only the Earth has a sizable moon. And as it would be even tonight, it's a beautiful moon to look at in the night sky. But why is it that we, the Earth, have this substantial companion and other terrestrial objects don't? It's a mystery. But what most scientists believe is that our moon is the result of a collision that happened early in the formation of the solar system. Now, the moon is back in vogue now because NASA has declared we're not going to go back to the moon, but we're going to go forward to the moon as the next step in sending humans to Mars. A year ago, when I talked about this at the time of the 50th anniversary, I said, time will tell if this is the latest case of us becoming moonstruck again. Well, a year has passed, and the world's a very different place, isn't it? Those in favor of going to the moon have their arguments. First of all, the technologies have come a long, long way in the last 50 years. Although I admit to impatience with the delays that are going on now, there are many reasons for them. They're political, they're managerial, and they're engineering. And it really does make me appreciate even more what a technical achievement the Saturn V was. Anyway, what we've learned about the moon in the last half century helps us to make the case for going again. Once it was thought that the moon was bone dry, and that's turned out not to be true. Moon missions by NASA and by India's space agency have found evidence of water in craters at the polar regions of the moon, illustrated here in blue. These are areas in craters where sunshine doesn't reach. India is profoundly proud of its space program. You may know that last September, they made an attempt to put a lander and a rover down in the southern polar region, and it failed. It was a tremendous disappointment for India. And I think by most accounts, the cause of the failure had something to do with software, which reinforces what I hear at JPL all the time from JPL veteran engineers. It's usually the software, not the hardware, that will get you. Anyway, the polar regions are prime real estate for exploration. Instead of a gold rush, think H2O rush. Because if you want to learn how to live off the land, as NASA says it wants to do, and establish a permanent presence on the moon or anywhere, you have to have water. And then there's China. China's space program is growing by leaps and bounds, and China's made no secret of wanting to exploit the resources of the moon. A Chinese rover launched a year and a half ago in January is roving on the moon, on the far side of the moon, where direct communication with the Earth is not possible. This is a very impressive technological achievement. And by the way, the rover landed in a crater named Theodore von Karman. Now, I don't know if you know that name, but that's the name of the first director of JPL. And you may or may not know that one of the very first rocketeers at JPL was a young Caltech student who became very much in charge of helping us to build our first rockets at JPL. He was deported as a spy back to China during the Red Scare and went on to become the father of Chinese rocketry. So I'm wondering if there's a bit of a jab going on there by the Chinese. I'm not sure, but it's interesting. Now, the larger point I really want to make is that we may be at the cusp of a new space race. A space race that this time is a multinational one, a moon rush where the prize is to stake out regions suitable for establishing a human presence on the moon. And those are the polar regions. Speaking of space races, Sputnik has been called America's technological Pearl Harbor. It was a shock to the American psyche. And the responses ranged from the reasonable, like placing greater emphasis on math and science in the classroom, for which I suffered greatly, to the extreme of even setting off a nuclear bomb on the moon to demonstrate America's military might. Now, that sounds crazy, right? But a number of well-positioned people in the United States toyed with this ideal. They included the scientist Edward Teller, the father of the hydrogen bomb, and JPL's director at the time, William Pickering. I'm sure you may know that it was JPL that led the combat response to Sputnik with Explorer 1. The engineering lore at JPL is that we, meaning JPL satellite and von Braun's rocket, could have been first into space, but Eisenhower wouldn't allow it. But that's a story for another time. Right now, let's go back to the time of Sputnik and see what happened. This is the first of 3 clips we're about to see from some documentaries that I've made.
In October of 1957, the Soviet Union shocked the world with the launch of the first Earth-orbiting satellite, Sputnik. America's response, a satellite called Vanguard, was also a surprising and spectacular event. Vanguard would be only one in a long string of setbacks for the United States space program. On a visit to the U.S. in 1959, Soviet Premier Nikita Khrushchev made sure to underscore the disparity between the two nations.
A successful moon rocket heralded Khrushchev's arrival in America, a scientific feat heavily capitalized on by red propaganda. It gave solid foundation to Khrushchev's boasts of Soviet achievement.
America's hopes for competing in the race for the heavens rested with its newly formed space agency, the National Aeronautics and Space Administration. NASA was given an assortment of technical facilities scattered across the country. One of them was the Jet Propulsion Laboratory in Pasadena, California. Of all the groups NASA inherited, JPL was a part. This research center was then, like today, managed and staffed by employees of one of the world's most renowned engineering universities, the California Institute of Technology. JPLers were accustomed to a tradition of independence. From JPL's perspective, NASA was a newcomer with no portfolio. In contrast, JPL had built missiles and the first successful U.S. satellite, Explorer 1. JPL was led by William Pickering. When NASA asked Pickering his ideas for the nation's robotic space program, an armada of spacecraft, he responded with an ambitious plan nearby planets. For JPL flying an armada of spacecraft to the moon and nearby planets.
One thing you can say about Pickering is that he was ambitious and had big ideas. But I don't think in later years that he was particularly proud of the fact that he was associated with Project Red Sox, which was what his ideal for blasting the moon with hydrogen bombs about. But it wasn't just Pickering and Teller. What you see here is the cover of a study that was done by the Air Force about the same ideal of nuking the moon. They were serious. It was a 250-page report. I read it all. One of the contributors to it was a student, a graduate student. His name was C.E. Sagan. That is Carl Sagan. Interesting to me that later on in his life, he was very much about the time of Cosmos. He became a very, very outspoken critic of nuclear weapons. Meanwhile, the Soviet Union continued to surprise and confound us. For instance, when Nikita Khrushchev made the first visit ever of a Soviet head of state to the United States, the Soviets timed it so that the trip would coincide with the first mission to reach the moon, Luna 2. And 2 weeks after that, they launched Luna 3 that took the first image of the far side of the moon. Now, this grainy image isn't much by today's standards, but at the time it was another technological triumph. And Eisenhower could only grin and bear the embarrassment. John F. Kennedy's presidential campaign included a lot of noise about how the US was far behind the Soviets with its missile program and how he was going to fix that problem. You can look from here and see some of these issues. I'm reminded of a phrase in Tom Wolfe's The Right Stuff that I always loved seeing, that he would sprinkle in of "our rockets always blow up." And it's not well remembered today, though, that Kennedy, in his inaugural address, slipped in a suggestion that the United States and the Soviet Union should try to explore space together. By the launch of Yuri Gagarin, the first human to go into orbit, changed Kennedy's mind. So a frustrated Kennedy wrote this memo to conduct a survey and find a way, any way, to beat the Soviet Union in the space race. What would it take, Kennedy wanted to know, to have a first in space? Putting up a space lab, a trip around the moon, landing a rocket on the moon, a man on the moon, or any other idea. And Kennedy made no secret of his impatience. He wanted to know if the people involved in America's fledgling space program were working 24 hours a day, 7 days a week. And if not, why not? To find the answers, Johnson turned to NASA's administrator, James Webb, and the US Secretary of Defense, Robert McNamara. Many years ago, I spent some time with James Webb, and he was very candid that he and McNamara were not the best of friends. And I'm not surprised that they had very different answers to Kennedy's question. Webb's position was that the only hope of having a first in space was that the United States would have to land an astronaut on the moon. McNamara didn't think that was even enough, and he argued for a mission to Mars, a human mission to Mars. Of course, as we know, Webb's proposal won out. Kennedy took the ideal to Congress and made his now very famous speech, proposing to land a man on the moon and return him safely to Earth by the end of the decade. Now, what's not really well known is that the "before this decade is out" line was a last-minute compromise. James Webb got a copy of the advanced copy of Kennedy's speech just hours before he gave it in Congress. And to his shock, there was a deadline mentioned, 1967. Webb convinced the White House to take out the year and say instead, "before the decade is out." So had 1967 stayed in, Kennedy's goal would not have been met. So now let's turn to JPL's role in getting footprints on the moon. Even before Kennedy's speech, JPL was working on 2 moon projects. The first was called Ranger. Ranger was designed to be a series of spacecraft that would take close-up TV images of the moon before crash landing on the lunar surface. But even crash landing on the moon proved to be far harder than anyone at JPL expected. Ranger 1 didn't work. Ranger 2 didn't work. Ranger 3 didn't work. Ranger 4 didn't work. Ranger 5 didn't work. And at this point, the lab stood down and regrouped. A year later, this was 1964, they launched Ranger 6. It worked perfectly up until the last few minutes before hitting the moon. It was then that the TV camera was turned on. No pictures came back. No pictures, no mission success. But let's see if they had better luck with Ranger 7.
You have 6 Rangers which fail. With each failure, the pressure on JPL became more intense, and after number 6, this was really a catastrophe.
I had no fear that the lab was going to fall apart. It was quite the opposite. Everybody pulled together, basically, what can I do to help?
6 months after the debacle of Ranger 6, JPL was ready to try once more. It had required working 3 shifts a day, 7 days a week.
The next one, 7, was a severe strain on everybody because it had to work. And if it hadn't worked, there's no telling what JPL would have been like or what would have happened to JPL. It was a sobering experience.
Launch through the 66-hour cruise was a textbook flight. 3 days after liftoff, JPL's auditorium was once again filled beyond capacity with people and tension.
Magnetic tape recorders were started at 130700 Zulu at both Pioneer and Echo sites. We are anticipating turn on momentarily. We are 5 seconds from full power. We have full power on F channel. Roger. Full power on F channel. All kinescope recorders are recording. All magnetic tape recorders are recording. Video is very strong. 10 seconds to impact. Video still good. Excellent signal strength. 3, 2, 1. Impact. Impact has occurred at 1325502. All video data was excellent right up to impact. All cameras were functioning. Transmitters were functioning properly. This is Gold Zone TV control. Oh, roger.
When impact occurred, the auditorium erupted in a great cheer. People shook hands and hugged one another. Some wept. One hard-nosed engineer likened the event to a spiritual experience.
Some people had smuggled in some champagne, and champagne bottles were opened. It was a great celebration.
Now, as a bit of an aside, I want to mention Mariner 2. Mariner 2 was sort of a souped-up Ranger. It's basically what engineers call the same bus, the same structure, just different instruments on it. And Mariner 1, like the problem of rockets blowing up, it had a problem with the rocket, and it went into the Atlantic. So Mariner 1 was a failure. But Mariner 2 was successful. It barely made it, but it limped by all the way to Venus and flew by in 1962. Now, this is 2 years before the success of Ranger 7. And Mariner 2 was the very first US first in the space program, beating the Soviets to a planet first. Now, here are a couple examples of how newspapers covered the event. And it's sort of hard to remind ourselves or imagine the incredible anxiety and now the relief that finally we were up to the task of challenging the Soviet Union. I'm also interested in the Two Hurt and the Minor riot at the Glendale bar, but I haven't figured out exactly what went on there. I have to do a little more research on that one. After Ranger came the Surveyor program. It was far more complicated and challenging as an engineering assignment. This was about soft landing on the moon, with multiple landers sending back images from the surface, and not just for a single day. The engineering work was done by Hughes spacecraft. And JPL and Hughes at first didn't get along very well. They didn't mesh. And you can imagine trying to get your work done with an engineer all but literally peering over your shoulder. But eventually the two groups reached an accommodation. And here's what happened.
Of all the questions NASA wanted answered, the most important was knowing what the surface would be like for Apollo astronauts. Was it solid? Or would layers of dust act like lunar quicksand and swallow them whole? NASA had hoped the answers would come from Surveyor. This was JPL's first experience in overseeing on behalf of NASA the work of an aerospace company. But the contractor, Hughes Aerospace, was struggling for good reasons. Surveyor was far more technically challenging than the Rangers. This spacecraft not only had to soft land on the moon, it had to do so autonomously. It was also expected to send back images and science data from the lunar surface, not for a day, but for weeks.
That was a difficult, trying period because we were growing up at the same time that Hughes was growing up. And we didn't always mesh. A trying time.
Shroud is off and Grand Bahama is tracking. As shown by the animated diagrams in the monitor, the Atlas Centaur separation has occurred.
63 hours after launch, Surveyor 1 was only 1,000 miles away from the moon, with the speed increasing as the moon's gravitational attraction beckoned.
Vernier ignition, retro is now firing, ignition looks stable. Falling steadily.
The vehicle was supposed to enter a fixed rate of descent. So that happens.
10,000, all signals normal. Surveyor reported in excellent condition, all signals good. 100 feet, 13 feet per second speed.
At a certain distance above the surface, the engines are all supposed to shut off. And then it's supposed to drop to the surface. And the engines all shut off. And you could hear a pin drop. It worked. We're down. It's still transmitting.
For the first time, an American spacecraft had achieved a soft landing on another celestial body. Surveyor 1 operated for 6 weeks. In all, the sturdy lander sent back more than 11,000 images before its batteries ceased to work. And NASA had the answer to its question. The lunar surface was solid and suitable for landing by the Apollo astronauts.
The Soviets were the first to land on the moon in one piece with Luna 9. It didn't crash land and it didn't soft land. Instead, it used airbags, the same technique JPL adopted to land Pathfinder on Mars 30 years later. It's interesting to make a comparison of the images of the lunar surface taken by Luna 9 and those by Surveyor. This is one of them. What they say to me is that being first doesn't always mean being the best. And the fate of the Soviet program suffered because of this relentless drive to be first. But for completeness, I have to mention one more first by the Soviet Union that few people know or remember. Would you believe me if I told you that the Apollo 8 astronauts were not the first Earthlings to fly to the moon, circle it, and return to the Earth? That's true. It's a fact. These were the first Earthlings to accomplish that historic feat on Zond 5. Now, it's easy to make fun of this, but that's not my intent. Zond 5 tells us that the Soviets were very serious about trying to go to the moon and to be first. But their version of the Saturn V, the N1, never worked. There's one more connection we can make between the Apollo program and JPL. In the midst of the triumph of Neil Armstrong's and Buzz Aldrin's landing on the moon, it was all but overlooked how close the mission came to an unsuccessful, if not disastrous, outcome. Apollo 11 landed with only 20 seconds of fuel left. And that was because the computer overshot the landing site. And when Neil and Buzz looked out the window, they realized they were headed for a field of boulders. Neil had to take over manual control and find a safe place to land. Well, Apollo 12 mission planners weren't going to let that happen again. And so a goal of Apollo 12 was to have a pinpoint landing. And to confirm the accuracy of the landing, they needed a landmark. But on the moon, there aren't any signposts. So what were they going to do? What they decided to do was to target a human-made object already sitting on the moon. One of the surveyors, this was the third surveyor to land. And here you see Pete Conrad, my all-time favorite astronaut, standing beside the surveyor with the Apollo 12 on the horizon. I don't know if you can see it, it's in the far right-hand corner there. Since they were going to be landing beside a surveyor, it was decided, why not bring back some surveyor to see how well it had weathered on the moon? Easier said than done. But Pete brought along with him a kind of hacksaw, and he cut off a number of pieces, including the surveyor's camera. And the crew brought it back home. When the camera was inspected later in a lab in Houston, there was the belief, at least by some of the scientists, that they found signs of microbial life. That somehow, before being launched off to the moon, someone had deposited microbes, maybe a sneeze, who knows, onto the camera. And the microbes had survived being on the moon for 3 years and came home to Earth, none the worse for wear. Now that has been pretty much discredited now. Perhaps someone sneezed on the camera after it came back. But what's important about this story is that at this time, scientists were beginning to understand that life is far more hardy and more tenacious than we ever knew before. And that meant there were real possibilities for looking for life elsewhere in our solar system. And for me, that's part of the legacy of the moon landing. The basic idea that searching for life elsewhere in the solar system is no longer confined to the realm of science fiction. Just as we saw at the beginning of this talk, right now we're working on a mission to explore moons that are serious candidates for possible life. So I would conclude by saying, I'd like for you to remember 2 footprints, one robotic, one human. What they say to me is that to go to the next great adventure in space will require both resources, the best robotic machines we can make and the best of the human heart. Thank you.